This is question 5 on page 331. It's got a little yellow triangle with a red exclamation mark in it, so it's supposed to be like more difficult. I just see this as an application of the sine rule. So let's just jump to it then. Working in red perhaps here. A tent is supported at A, so there it is, there's A there. You know, A, like an angle maybe in a triangle, by two guide ropes AB, so A to B is a rope, and A to C is a rope, clearly displayed here, beautiful. AB is 1.8 meters long. I better just write that in. So AB is 1.8 meters long. And AC is 2.1 meters long. Alright, well let's just write in there in yellow. So A to C is 2.1 meters long. The angle ABC is 72. So ABC is 72. So let me just join the bottom there in yellow so it stands out, make a little triangle, and I'm told that this is 72. Read it again. ABC, B is the important part, is 72. So 72 degrees. Maybe just put a blue on that so it stands out. 72 degrees, that bit. So what have we got then? Calculate angle BAC. In other words, they want us must to calculate that angle right there. So BAC is the A angle that they want. Alright? So that really is an angle there. Let's just go over that a few times. So let me just clarify this by drawing the picture again. We've got ourselves a triangle like so. Just make it a little bit more facing us. We've got A at the top, we've got B there, we've got C there. We have 1.8 meters here, we have meters, we have 2.1 meters over here, we have 72 degrees over here, and they want me to work out this angle right here. Oh really? Angle BAC. AC is 2.1, AB is 1.8. So that goes with that, and that goes with that. Okay, now listen, don't worry about it, but look, the 72 corresponds to the 2.1 over there, but the 1.8 corresponds to the angle at C. So what I have to do, I cannot get angle A directly in the first instance, I must get angle C first, and then of course take away the 72 and angle C from 180, and then I'll get my A. Alright, so alright, a bit of a problem solving thing. So here we go, let's just do the sum because it's really easy. Right, so I want C divided by 1.8. So C divided by 1.8, well it's actually the sine of C, isn't it? Because we're playing with angles. So the sine of, let's make it clearer, let's go in black so it stands out. Here we go, that's better. So the sine of angle C divided by the length of 1.8 meters is exactly the same as comparing angle 72, or rather the sine of angle 72 degrees, by his length 2.1 meters. Alright, so sine C over 1.8, yep, they go together, and sine 72 over 2.1, yep, they go together. Again, take the 1.8 over and multiply. And multiply the length 1.8. Let's get the sine of C straight away. So we've got sine 72 divide by 2.1 multiply by 1.8. Bam. So that's the sine. I was about to say shift sine. We'll do that in a minute. So 0.8191912999 whatever, doesn't matter, and therefore angle C degrees is going to be the shift sine of that. Bam, and that gives me 54.6 degrees. Therefore, let's just conclude in blue. Therefore, A is going to be 180, take away the 72, take away the 54.6, because we now know that is 54.6 degrees, and that's going to give us, let's just work it out, 180, take off the 72, and take off the 54.6. Boom, 53.4 degrees. I think that's a lovely question. All right, there you go. A sine rule question in context. It's all about finding angles and ropes and what have you. Here's the next one. Oopsie daisy, bearings. Let's just have a look at it. It says, get back to red I think, 2 Coast Guards see the same boat. Well, there's the boat right there, and we have a Coast Guard there and there presumably. Yeah, Coast Guard Y is 4.2 kilometres due south of Coast Guard X. So that's 4.2, that's Coast Guard X, and that's Coast Guard Y. We're also told the boat is on a bearing of 118 from X. Yep, going clockwise. There's the boat. And 071 degrees from Y. Again, 3-figure bearings, so you're just shoving the naught there as a question of style. So 071 degrees is 71 degrees. There it is, going clockwise, going towards the boat. Calculate the distance of the boat from each Coast Guard. In other words, I've got to know this length here. Let's just call it, I don't know, A. And this length here, shall we call it just B? Alright then? So let's just work out all these little bits and pieces here. Now, I've got a bearing of 118 degrees there, but I want to work out the angle inside this triangle that we've created, and that's going to be 180, of course, take away 118, and that leaves us with 62 degrees, if I'm not mistaken. Yeah, I think that's correct. So what have I got? I've got 62 there, and that goes with the B, and I've got 71 there, and that goes with the A. And at the moment, what I've got is 2 unknowns, so I've got to find a way of getting another angle with a length somewhere. So let's just work out this angle here then, because I know that's 62 degrees. If I write it right there, it becomes part of the triangle. So 62, 71. Now I can work this out by taking the other 2 away from 180. So I'm going to say 180, take away 62, and take away the 71, barely visible I'm sure, and that's going to be, let's get rid of that equals there because B is not equal to that, it just happens to be in the way. That equals 180, take away the 71, take away the 62, and that's going to give us 47 degrees. So that's really important we get that. So that's 47 degrees. So right, just quickly reiterate. 62 because we're on a straight line, so 180 take away 118, 62, and that's 71 given anyway. These two subtracted from 180 gives us 47 degrees for that angle towards the boat. Now we can play. So A and 71 go together, 4.2 and 47 go together. So let's just do one in red and one in yellow or something. So A divided by 71. Remember, we're working out distances and not angles. So distance on top, A divided by the sine of his opposite angle, 71 degrees, is just like comparing 4.2 kilometers divided by his opposite angle. Okay? Divided by his opposite angle, which is going to be, of course, the sine of 47 degrees. I say divided by his opposite angle. It's divided by the sine of his opposite angle, you understand. So, to get A on its own, therefore, we need to go 4.2 kilometers divided by the sine of 47, and then just multiply by the sine of 71 degrees, because we're just taking it over and multiplying as usual. And we don't need to shift sign anything because we're working out a length. We just go 4.2 kilometers divided by the sine of 47. Not really clear. Make it nice and clear. Right, divide by sine 47, and then we're going to multiply by the sine of 71, and that gives us 5.43. Let's go one decimal place because that's 1 dp, isn't it? So that's going to be 5.4 kilometers away. So that's that. In the same way, I can work out the length B by linking B with the opposite angle 62 and the 42 kilometers again with its opposite angle of 47 degrees. So let's just work in a different colour down here. B then. So B is what I want to put it on top. So B divided by the sine of 62 equals the length 42 kilometers. That's that length divided by his opposite sine, the sine of 47 degrees again. Get B on its own, 4.2 kilometers divided by the sine of 40. So let's have a look. 47, yeah, 47 degrees. and then multiply by 60, so you just sort of bring it over like that and multiply, as you know, times the sine of 62 degrees. So how do you get B then? Punch those numbers in, listen to me speak. So it's 4.2 divided by the sine of 47 and multiplied by the sine of 62, and that gives us 5.07, so it's 5.1. So you're looking at 5.1 kilometres to one decimal place. So what do we got then? Length A from Coast Guard X to the boat, you're looking at 5.4 kilometres, and the length from the boat to Coast Guard Y and Y to the boat is going to be 5.1 kilometres. And I think that's a really, really nice question. I'll stop there because the next time we meet up, we're going to be doing the cosine rule. Okay, go back to the very introductory video I did, very introductory video, when I introduced the standard trigonometry and then reintroduced beyond that the sine and the cosine rule. So have a look at that if you want to, or just wait for the next instalment and you'll get it anyway.